Lesson 14 demo. We're going to explore two new kinds of transformations. The graph below shows the parent function f of x equals sine x. That's the same graph that we were just working with in the preview exercises. And the transformed function g of x 2 times the sine of x. So sine of x is graphed in this maroon color, and 2 times the sine of x is graphed in blue. So I want to describe the effect of the outside multiplication by 2. So my 2 is outside of the sign, right? It's not inside the parentheses with the x. It's outside multiplication by 2. So what it looks like is the blue graph just looks taller, right? It looks like I just took the red graph, sine of x, and I stretched it vertically. So vertical stretch. And then the question is, how much did I stretch it by? So it used to be that my lowest point on sine of x was -1 and my highest point was 1, right? So my range was -1 to 1. And then my range goes from, it becomes -2 to 2, right? So I went -1 to 1 was my old range, and it became -2 to 2. So this has a length 2, and this one has a length of 4. So it looks like my range length doubled. And that makes sense because I was multiplying by 2. So I'll describe this as a vertical stretch by a factor of 2. The word factor indicates multiplication, right? It's part of a multiplication problem, or it's factors. So it's a vertical stretch by a factor of 2. What do you think would have happened if I had multiplied by a half instead of by 2, right? If I had done, my new function was g of x equals 1/2 times the sine of x. I predict that this would have been a vertical shrink. Everything would have shrunk, multiplying by a half. So vertical shrink by a factor of 1/2. And here is a parent function, sine of x again, and I have a new transformed function, sine of 2x. So this is a little bit different. Instead of putting the 2 outside of the sine, now it's inside the sine function. So I'm multiplying by 2 on the inside. The x value is what's changing. And I have my original sine of x is the maroon colored curve here. And then the red curve is the sine of 2x. And I want to describe the effect of that inside multiplication by 2. So my maroon curve looks wider. It looks like I took that maroon curve and squished it from the left and the right, squished it so that it would take up less space horizontally. So I would call this a horizontal shrink. Right? So I squished this, or a horizontal compression, you could call it. And by how much did I shrink? So well, let's measure the distance from peak to peak and see if that can tell us how much we squished. So on my original, I have a peak from there, and then my next peak is over here. So peak to peak, that distance is 1.57 to 7.85. Get my calculator here. 7.85 minus 1.57 is 6.28. So my distance from peak to peak on my original graph was 6.28. And then if I look at a distance from peak to peak on my new red graph, let's see, that's going to be like, I'll do a min to a min, here to here. That distance, well, that's a little harder because these aren't labeled. Let's say 3.14 plus 1.57 divided by 2. This point here is 2.35. And this point here is halfway between 4.71. I think that's what that is. Plus 6.28 divided by 2. So this is about 5.5. And then Oops, sorry, this is about 5.5. So the distance between those two bottoms, those two minimums, is 5.5 minus 2.35, 3.15. That's about half the distance of 6.28. 6.28 minus 3.15 is divided by 2 is 3.15. So we shrunk the distance from peak to peak by a factor of 1/2. It's 1/2 of what it used to be. So this is a horizontal shrink, and we describe that shrink by saying by a factor of 1/2. Okay, so it was multiplication by 2, right, in the formula, and that became actually a factor of 1/2. So just like with shifting, when you're doing multiplication, it's sort of the opposite of what you think is going to happen when you're inside the parentheses. When you're outside the parentheses, like we were up here, we were multiplying by 2 and we stretched by a factor of 2, right? But when you're inside the parentheses, like in this guy with the sign of 2x, you have multiplication by 2 in the formula, but that causes a shrink by a factor of 1/2, sort of the opposite of what you might think. So what do you think would have happened if we had put a 1/2 in front, if this g of x were the sine of 1/2 x? So I think the opposite would have happened, right? This would have been a horizontal stretch by a factor of, so it was when I multiplied by 2, I actually shrank by a factor of 1/2. To reverse that, multiply by 1/2, that's going to cause a stretch by a factor of 2.